40 years ago, if you went to a drugstore, you'd see something that doesn't exist today, a tube tester. Up to the 1960s and 70s, most radios and televisions used vacuum tubes, or valves as they're known in some countries. Almost every drugstore had a self-serve tube tester where you could bring in your tubes, test them, and buy replacements if they tested bad. When electronics went solid state, this became a thing of the past. The consumer tube testers were large and provided storage for a selection of new tubes. Tube testers were also sold that were aimed at engineers, manufacturers, radio and television repair technicians, and hobbyists. One such tester is the EICO 666 I have here. Because tubes had a limited lifetime and were relatively expensive, they were designed to be easily replaced. A tube tester is a piece of equipment that can determine if a tube is functioning or not. The book Tube Testers and Classic Electronic Test Gear goes into great detail on how tube testers worked and the different models that were on the market. Essentially, there are two major general types of testers. Vacuum tubes rely on an effect called thermionic emission, where electrons can flow in a vacuum when emitted from a heated element called a cathode. The heating is performed by an element called a heater, which is similar to a light bulb filament. The most basic testers can do an emission test that verifies that current can flow through the tube. On all but the very lowest cost tester, a meter usually gives some indication of the level of emission. Most testers will also test for shorts between the elements. This is typically done first before an emission test. Most tubes can amplify a signal. A measurable value of the tube's ability to amplify is known as its transconductance. A more sophisticated tester can measure the tube's actual transconductance value. Because of the complexity of doing this, most testers perform a simplified version of this test, often calling it mutual conductance or dynamic conductance. The Electronic Instrument Company, or EICO, was a producer of inexpensive test equipment, some of it offered in kit form. They started offering tube testers in 1950. This model 666 was introduced in 1956 and sold for $69.95 in kit form and $109.95 assembled. It was followed by a model 667 which was on the market until 1974. This is a mid-range tester that doesn't measure true transconductance, but is better than a simple emission test. It supports 10 different types of tube sockets, covering all the major form factors of tubes going back to the 1920s. It's in a briefcase-like metal carrying case and has a built-in roll chart. The roll chart lists the testing parameters for each tube type. It was common for them to be errors in the roll charts, and the EICO 666 had more than its share of them. Over the years, different revisions to the roll charts were offered. If you have a tester, you can search the internet for newer roll charts that were usually more accurate. Also, old charts may be needed for older tubes that were considered obsolete and removed from the chart. This unit could also test picture tubes with an adapter. It also claimed to be able to test transistors. I didn't have any luck using this, and I don't know of anyone using this feature for testing modern transistors. There are 10 switches that connect up to 9 socket pins and the tube cap to one of 6 buses: ground, heater, screen, plate, grid, or open. 2 more switches select voltages for screen, grid, and plate, and the meter range. A selector switch controls the heater voltage. 2 controls adjust grid and plate voltage. Push buttons perform short or merit tests on a specific pin. The control calibrates the tester for the AC line voltage. Let's see a demonstration of testing some actual tubes. On power up, after letting the tester warm up, we should perform a power line adjust by pressing the line switch and adjusting the line adjust control for a center reading on the meter. Without this, changes in the AC line voltage would affect the consistency of readings. We're going to test a 35 Z5 GT diode rectifier tube. We first look up the tube on the roll chart, which lists them in alphabetical order. And here it is. We set the filament voltage, 35 volts. The grid setting, 0. and the plate 771, and the 12 selector levers. 1, 2, 6, 1, 3, 1, 1, 1, 1, 1, 4, 1. First we check for shorts. Put the tube in the appropriate socket. It accepts all the common and some less common tube types. Other examples would be miniature and loctile. This is what's known as an octal tube. First we test for shorts. The tube that fails a shorts test is bad and should not be tested for merit, as it could damage the tester. For this tube, the short tests are 5 and 8. 5 and 8. Pin 8 has an underline indicating that this is actually a heater cathode leakage test, and we need to press the HK leak button while we perform the test. For leakage, we should get a reading very close to 0. These tests pass, so we now move on to the merit test. The merit test is pin 5, so we press 5 and then pull the merit lever and read the result. In this case, it's in the good range. Note that you need to wait a few seconds for the tube to warm up after inserting it before doing the merit test. Now let's test another tube, a 50L6 GT tetrode. Look it up on the roll chart. Filament voltage is 50. Grid 7. Plate 94. Switch settings 1, 2, 4, 3, 5. 1, 1, 1, 1, 1. 4, 1. And the shorts tests are 3, 4, 5, and 8. And 8 is a leakage test. Merit test is 3. And we get a reading on the low side in the replace range, so this tube may be weak. I'll have more to say about that later. Now here's a handy little feature. You can test the lamp using the center of the 7-pin socket. Set the filament voltage to the appropriate voltage for the lamp. Here, number 47 bulb and 6.3 volts. And we can test the lamp here. So you can use this for lamps of various voltages, Christmas tree bulbs, and so on. When using a tube tester of this type, there are a few gotchas to watch out for. For best accuracy, adjust the line adjust again after setting the controls and inserting the tube. Turn the filament voltage to 0 after testing the tube. If you forget to do this, Murphy's Law will ensure that you'll plug in an expensive 1-volt tube after using it to test a 50-volt tube and immediately burn out the tube's filament. Reset all buttons before testing a new tube, or you may apply a voltage that can damage the tube. Some tubes have multiple lines on the roll chart for testing multiple elements. Don't forget to perform all tests. And finally, if you get strange results, it's possible that there is an error in the roll chart. You can compare the settings for different revisions of the roll chart and see how they compare. Or compare the result to another tube of the same type if available. I'd like to conclude with a few somewhat surprising facts. In old radios, one of the least likely failures is a bad tube. Unless a tube is physically broken, much more likely problems are electrolyte capacitors, the symptom being a loud hum, leaky wax paper capacitors, or carbon resistors that have changed value. And after all these years, tubes are still available, both used and what's called new old stock, old tubes that have never been used. Some tubes are still being made in Russia and China for markets like electric guitar amplifiers and amateur radio transmitters. There are only a few tubes that are now extremely hard to find. Getting back to the drugstore tube tester, it's sometimes said that the purpose of tube testers was to sell tubes. These testers were often calibrated so that many tubes would test as questionable or weak to get the customer to purchase a new tube. Because most tube testers don't measure transconductance, they only give an approximate result. The best test for a tube is the circuit it runs in. Don't throw out a tube because it reads weak on a tester. It may work fine in a radio. Discard it if it is physically broken, has a burned out heater, or shorts, although even shorts are okay in some cases if those elements are not used. A tube tester is a fun instrument with lots of shiny knobs and switches, but it's not necessary unless you have a need to test many tubes. When I restore an old radio, if it works well after replacing the capacitors and out-of-value resistors, I usually don't bother to test the tubes. I also don't stock up on old tubes. Hundreds of different tubes are manufactured. I rarely need a new tube, and if I do, it's invariably one I don't have, so I only buy tubes when needed. Of course, over the years, one tends to acquire tubes, as you can see here in my tube junk box. That said, if you have an old radio that's important to you, you might want to purchase a spare set of tubes for it for future replacement. The stock of old tubes won't last forever. I hope you enjoyed this presentation on an old tube tester. Watch for my other videos on vintage ham radio and test equipment.